If you notice again on these notes, kind of like last class, I filled in a lot of information because I don't want to sit here and take a lot of notes. I'd rather get out into the hallway and practice with our questions that are in the scavenger hunt gallery walk in the hall. But let's go over some of the main important ideas and let's highlight our notes so that they're more useful for us. This is going to be a really important day to have like 4 or 5 different highlighter colors, which means we're going to have to share the highlighters. We're switching units as well. Unit 8 begins today. Unit 8 is all about what is called similar figures. I believe you've talked about this before in 8th grade, but it's been a hot second since we've all been in 8th grade. So let's go back over the idea of similarity. If 2 polygons are similar, that occurs if and only if their 3 corresponding angle pairs are congruent and the measures of the 3 corresponding sides are proportional. So we're going to toss it back to doing some of our proportion work like we've done way back when we started to learn about how to solve algebra problems. We're going to do proportional work today. Now the symbol for similarity is just the little tilde. The little squiggly, one squiggly line means similar. When we used a squiggly line on top of an equal sign, we said congruent. But for similar, it's just the squiggly line. So if you want to highlight that, that might be something good worth highlighting right here, that is the symbol for similar. When you see that symbol, I'm telling you that 2 things are similar to each other. So their angles are all the same, and their sides are proportional, or are a ratio, a fraction. Second thing today is scale factor. When I'm talking about scale factor, which is going to be the letter K, I'm talking about how much you multiplied or divided by to make one small triangle into a bigger triangle, or one small side segment into a larger side segment. We've technically done this scale factor before when we did transformations. So your project where you took your image, you made it bigger, smaller. We used a scale factor there. It's the same idea. The formula for scale factor has not changed. If you want to add a little extra, I know I clouded it on your notes, but if you want to add some color to your cloud, this is the formula you're going to use to find the scale factor. It is just the ratio of the new length divided by the original or the old length. New divided by old. The last part, and we've already covered this in a different chapter, but we're talking about corresponding parts. Corresponding parts are all going to be congruent for similar triangles. So if I give you the information that triangle ABC is similar to triangle DEF, then we know the following. Number 1, we know that all of the angles are corresponding, are congruent. So in this image here, we have angle A in the same spot as angle D. I know they're in the same spot because of the arc mark. You see how there's one tick mark for both of them, one arc mark? They're similar. They are congruent, which means A and D are the same degree measure. Because B and E have 2 arc marks, they are the same. And because C and F are the same arc marks, their corresponding angles are congruent. They're the same numbers, period, no change. But what that also means for me is that the ratios of the corresponding side lengths are the same. So the numbers themselves won't be the same, but the ratios will be the same. The ratios will be equal to that scale factor K. So what I mean by this, and I'm going to get kind of colorful here, so do your best with your color coding. Let's say I'm going to highlight DE. So DE is right here. I'm also going to highlight AB. Do you see that those sides of the triangles on the old and the new are like the same sides? They go from 1 arc mark to 2 arc marks, 1 arc mark to 2 arc marks. So I can put them in a fraction, like a proportion. Continuing to color, if I highlight EF and highlight BC, around this triangle, they're in the same spot. So the ratio of EF, new, divided by old, BC, will be the same as the ratio for the green stuff. Last but not least, if I look at FD and CA, the last side lengths. No, those side lengths aren't exactly going to be the same, but their ratio is the same as the scale factor. So these side lengths are going to be similar. They're going to be multiples of each other because it's a ratio. So our goal today is to be able to determine missing pieces of information within different sets of triangles. I might ask you for a missing angle. I might ask you for a missing side length. I might ask you for a missing perimeter. I might ask you for a missing area. And if you know that information for one of the triangles, you can tell me the information for the other. We can even do this for different shapes, not just triangles. So let's see an example. Now that we've got all of the info up there, I've started most of these, but I need your help finishing. It says in the diagram, triangle RST is similar to triangle XYZ. Let's color code first so that we make sure we are thinking correctly. If I go from R to S, in my letters, those were the first two letters of this triangle. What are the first two letters of the other triangle? So I'm going to highlight with the same color XY. The next, or the second set of letters is ST. So I'm going to highlight ST with a different color. In the second set of letters, what is the second and third letter? YZ. So YZ get highlighted the same color. They're going to be proportional to each other. And obviously there's only one side length left, so those two are going to have to be the same. Okay, I can tell because these are similar triangles that my angles that correspond will be the exact same and that the ratios of the side lengths will be the exact same. So I gave you one of them. I said, all right, R is congruent to Z because R is in the same spot as Z. Sorry, I said Z this whole time. That's a whole X. R and X. R is surrounded by green and red. X is surrounded by green and red. Do you see that? Okay, so help me out filling out the rest of them. If I want to talk about angle S, which other angle is angle S congruent to? What's in the same spot as S? Y. So we're going to say angle S is congruent to angle Y. What's the last angle I haven't talked about yet? T. What angle is angle T congruent to? Z. Multiple reasons I know this. One from the image. Two because of the order of the letters. We have R first, we have X first. They're the same. S in the center, Y in the center, they're the same. T at the end, Z at the end, they're the same. Yes? We've done that before technically. But what we haven't done before is talked about the ratios of the sides. So part B, I want to write the ratios of the corresponding side lengths to make a statement of proportionality. Notice that the one I gave you was the red side. So we've already taken care of the red side lengths. Let's do blue next. What are the blue side lengths? What are the names of the blue sides? T and S and Z and Y. Now, which one goes on top? This is a great question. ZY. Why do I put ZY on top? It's the new one. So if this is the old one, that means this is the new one. Also, because of the ratio I wrote, I put the letters XY on top. So I got to stick with that triangle being on top. I can't switch them back and forth. Which means in the bottom, I should write ST. That leaves us with just the green sides left to write down. What letters should I put on top? XZ. What letters should I put on bottom? RT. Very good. Now part C here is going to actually have us calculate some stuff. It says find the scale factor from RS to YZ. Again, that is from our old to our new. So we just need to actually do one of the ratios we wrote in part B. You can choose any of them to calculate K. Do you all want to use the red, the blue, or the green? Truly up to you. Blue. All right. So give me the blue numbers. What is the length of YZ? 18. What is the length of ST? 30. If you go into your calculator and you do 18 divided by 30, it's going to tell you 3/5 or 0.6. Both of those are appropriate answers if I were to ask you what is the scale factor. You just have to do one of the ratios and just divide those numbers. All right. The next problem is kind of a doozy, so I've done all of the work for you. You just have to draw the right conclusion. It says the corresponding angles are congruent. We're going to decide whether the shape ABCDE and the shape KLQRP are similar and explain why or why not. There's a lot going on here, so let's color code because I think it would be helpful to see. Let's highlight LK, POW, and then also BA. POW. Switch colors and highlight the next set of segments. KP, AE. Do you see how I'm highlighting? I'm going to let you finish highlighting without me saying anything out loud. So highlight the corresponding sides. They're all labeled for you so you can see them. As you're going to continue highlighting, I'm going to start talking. If you notice right underneath all of those ratios we highlighted, I changed all of the LKs and BAs to the numbers on those sides. So on LK, it says 8. So I put an 8 right here. Do we see how I did this? And then for AB or BA, it says 12, so I put a 12 here. I wrote down all of the ratios. And then I went to my calculator and I calculated to see what those ratios are equal to. And if you notice, almost all of them are 0.67. But the very last one, is it also 0.67? Is that ratio the same? No. Since all of the sides do not have the same number when I do the ratio, we say that these are not similar. They are not similar because of this right here. The work would be explaining your answer. You show me all of the ratio numbers, and then the fact that this last one is different means that they're not similar. All of those numbers would have to be the same for it to be similar. So if you get one number that's different, you're done. They're not similar. Yes. Yes. Problem 3, we're going to work all the way through. This is from an SAT question. So if you're somebody who's taking your SATs soon, this is a good one to start listening to. That's all my juniors. Juniors, you take it at the last week before spring break. Here we go. It says triangle ABC is similar to triangle DEF. So let's draw. It's amazing to always draw an image. So our old one is going to be labeled A, B, C. And our new one is going to be labeled, oops, let's make it look a little bit better, D, E, F. Now, because I know that they're similar, I can draw arc marks to make them look similar. That means with A and D, I'm going to give one arc mark. For B and E, I'm going to give 2 arc marks. For C and F, I'm going to give 3 arc marks. I know that these triangles are similar, so I know that their angles have to be congruent. It goes on to tell me that angle A is 90 degrees. So I'm going to pop a 90 right there. It then also says that angle E is 53 degrees. It wants me to find angle C. which means I'm trying to find this right here. Now I'm telling you right now, we have enough information to do this. How come I have enough information to do this? We know that to find the missing angle in a triangle, you know that all the sides add up to 180. So I know that if I wanted to find angle C, I would just need to subtract the other angles away from 180. That means I'm going to subtract 90, and I'm also going to subtract whatever angle B is worth. But what's angle B worth? Ooh, 53. How did you know it's worth 53? Absolutely. Notice we have 2 arc marks on E, 2 arc marks on B. So what does that mean that B is equal to? Also 53 degrees. So to solve this question, just like we did last class, and y'all did this last class, you would take the 90 plus the 53 degrees. That's 143 degrees if you don't trust me. And then what do I do to find that missing angle? I would subtract 180 minus 143, which fast forward, because I trust you can put that in a calculator, would be 37 degrees. So angle C is equal to 37 degrees. So angles, immediately similar. That means they're immediately congruent. Ratios of side lengths just become the same fraction when you reduce it. On the back, we're going to go a little quick because, again, I've done a lot of the work for you, but I do want you to highlight with me so that you have a correctly highlighted graph. Our old triangle is DEF. Our new triangle is MNP. So let's highlight. If I go from D to E on the first triangle, the old one, I'm going to highlight M to N on the new one. If I go from E to F on the old one, I'm going to go from N to P on the new one. If I go from F to D, I'm going to go from P to M. I'm following the letters in the title of the triangle. Now I've already done the work for you, so let's just view what I did. I said K is going to be equal to the old divided by the new. So I took the old ratio for the red side lengths. I did 18 divided by 15. I picked the red sides. I just picked two similar sides, corresponding sides. And I found out that K is equal to 1.2. Fabulous. Check done, that's the scale factor. The second part here says find the value of X. Okay, well, X is a blue side length. So I definitely needed to use the blue number. And then all I needed to do was choose any of the other ratios that I already know. So I just used the red one again because I already knew that ratio. If that problem was set up for you, the one we've just highlighted, this is a cross multiply and solve problem. This is your butterfly method. So follow along with me. We do 30 times 15, and I would get 450. I do 18 times x, and I would get 18x. Do we see how I got my next step right there? What did I do to solve for x? I divided by 18 on both sides, which is like the last step of the box method, so that I could solve for x. That was a simple solve, so I didn't need to use the box method. Do we follow? Okay. On number 4, it's a similar question, but it's a little bit more complicated. Let's start by just understanding which sides are connected together. So it says OPR is similar to YXZ. So if I go from O to P, let's use a highlighter, Miss Quigley. O to P, and then that's the same as Y to Z. P to R, X to Z. R to O, Z to Y. So now I know which ones are going to be similar to each other. This problem wants me to solve for X. So if you notice, there are two side lengths with X on them, a red side length and a blue side length. I need to use the reds and the blues to set up a proportion. Do we see how I did that? Reds on top of reds, blues on top of blues. This is still a cross multiply and divide, but it gets a little complicated, which is why I'm going to call it cross multiply and solve. When I cross multiply and there's a binomial, meaning there's a plus or a minus sign in what I'm multiplying by, here and here, I have to do distribution. So annotate with me, because I didn't draw my arrows, my bad. I'm going to do 40 times x, and I'm going to do 40 times -4. I also have to do 16 times x and 16 times 10. But then after that, do y'all see what I did? What's going on in this problem after I do distribution? Y'all are good at this. What is this called? Box method. Because once I have an equation written out with no parentheses, I can just do box method, boop, boop, boop. I can figure out what x is. And that's what this question asks for. It says, what is the value of x? So, pow, I know what the value of x is. This is going to be a great example to look back at because it's about as complicated as it can get. They can be really easy, like number 3, or pretty complicated in the solving part of it, like number 4. The setup was exactly the same, so the geometry, exactly the same. The algebra could vary in difficulty. The next two sections are going to apply what we know about similar figures to perimeter and area. So let's highlight these words right here, perimeters of similar figures. That way you know where to look when it asks about perimeter. Theorem 8.1 says if two polygons are similar, polygon means shape, then the ratio of their perimeters is equal to each other. Is equal to the ratios of their corresponding side lengths. So what that means for us is we can take the perimeter, which is adding up all of the sides, and set it equal to one of my ratios for each side. We're not going to highlight this one because it's way too complicated to highlight, but we will highlight question number 6. This is an example of using this theorem. It says that RSTU is congruent to ABCD. It wants me to find the ratio of their perimeters. Okay, so first of all, I need to know their perimeters. Perimeter is just adding up all the sides. So for the smaller one, I did 14 plus 14 plus 8 plus 8. Does that make sense? Finding perimeter is adding up all of the sides. So 14, 8, 14, 8. I got 44. When I try to go do that for this guy, though, do I know this side length? So I got to figure it out. Because I need to know those numbers so I can add it together. So what I do is I think about proportionality. S and T are on the same side as B and C. So I use the ratio of S and T to figure out the ratio of 14 and my question mark, or my variable x. Instead of using a variable, I left it as a question mark just for funsies. Now this question right here looks exactly like the one we did in problem number 3. So I cross multiply and solve, multiplying the numbers in a diagonal. And then I divided by 8, which I didn't show my work if you want to show me what you did. And I got that the question mark side is 21. So that means my question mark is equal to 21. So I can do 21 plus 21 plus 12 plus 12. I get that the ratio of that perimeter, is 66. So here's one perimeter, here's the other perimeter. My ratio is the new one divided by the old one. So I did 44, the new one, divided by the old one, 66. And I just reduced that fraction, and I got 2/3. Now that was a lot of work, because we had to find perimeters, there's a whole missing side, it's a whole thing. But the theorem tells me that I can take a shortcut. The ratio of the perimeter is going to be the exact same as the ratio of just one of the sides. 8 divided by 12 is also 2/3. So you can find the perimeters, old divided by new, or you could just use one of the side lengths, old divided by new, and it's going to be the exact same. Number 7 is also a really good SAT prep question. I've seen a lot of questions like this on the SAT. It says 2 polygons, shapes, are similar. The perimeter of one polygon and the ratio of the corresponding side lengths are given. Find the perimeter of the other polygon. Well, it says that the ratio of the small divided by the large is 2/3. I'm getting that from right here. They gave that to me. If the perimeter of the smaller polygon is 48 centimeters, that means I'm going to put 48 centimeters on the smaller side. And I don't know the perimeter of the larger one, so I'm going to put an X right there. Let's solve this together to make sure we understand the butterfly method. We do this first. What is 2 times X? 2X. Okay. Then I go the other way. This might be a calculator question. What is 48 times 3? 144. I'm one step away for this problem of finishing because I want to cross multiply and then solve. What's the last step to solve here?
It's the divide.
It's the divide. So we do 144 divided by 2. I get that X is equal to 72, which means that is the perimeter of my larger polygon. The perimeter of the large polygon would be equal to 72 centimeters. SAT loves these kinds of questions, giving you random bits of information. So you remembering that the perimeters are proportional is really easy. The last bit here, keep holding on with me and then we'll get to practice where it's more easy for your brain to think. Areas of similar figures are kind of the same, except since area is a two-dimensional measurement, length times height, we have to square all of these terms when we do the ratios. So instead of just being equal to the regular numbers that you get out of the image, you're going to have to square those numbers. Since it's area and it's in 2 dimensions, so you square it. Length times width. So if I were to set up this problem for number 8, I have to make sure I square some stuff because it's area. It says in the diagram, triangle ABC is similar to triangle DEF. We're going to find the area of DEF. We were given the area of ABC. We were also given that these 2 side lengths are similar. So when I set up my proportion, when I did this for perimeter, I just got to set it up and go. But when I set it up for area, I have to make sure that I square this term because area is 2D. So I do 5 times 5, which is 5 squared. I would get 25. And then I do 10 squared, which is 100. Those are the numbers I actually use to solve my proportion. We cross multiply and solve. So it is exactly like perimeter, but again, because area is a 2-dimensional measurement, we have to square it. Length times width, so square. Let's finish this one together. I've set it up for you. We know that these are similar, so So KJ and PN are going to be my lengths that I use. This is the old. This is the new. New goes on top, old goes on bottom. If you need to write that down for yourself again, that's fine. New goes on top, old goes on bottom. So when I set this up, I put 21 on top and 7 on bottom. And then I set it equal to the area on the bottom. But before I do this, because it's area, I need to square that term. This is a calculator question. What is 21 squared? So 21 times 21 is 441. What's 7 squared? 49. That's going to be equal to x over 84. We cross multiply, we divide. 49 times x is 49x. 441 times 87 is 37,044. I'm fast forwarding because I know we know how to type stuff in a calculator. Is that okay with everybody? To solve for x, we divide by 49. We would get that x is equal to 756, which means for me that the area of LMNP, the other triangle, quadrilateral, is 756 meters squared. So we're solving proportions today. The proportions are of the side lengths, are of the perimeters, or are of the area squared. Now we've not really practiced any on our own, which is what your classwork today is going to be. There's a gallery walk in the hallway. We're sharing with Miss Caldera's class, so like normal, we're gonna have to elbow our way into them. You are working with the team that you did the crossword search with this morning. So you already have a team built in to work with. You're going to take your gallery walk paper and a clipboard out into the hallway to work. And it's a normal one where the question is on one card and the answer's on another. Y'all know what I'm talking about? We've done this enough times where you should get it. You are finishing this before you leave. So you're going to turn in what you have and it will be your grade for today, which means you need to get this done now, not at home. You're not taking it home with you at all. You have 12 questions out in the hallway to practice. Some of them are harder than others, so take your time, work through them as well as possible.